Good morning. My name is Lamar Hines, and I'm going to take you through a quick demonstration on using one of the toolkit programs for parallel transformers. Okay, and actually, this is the menu screen that you'll see when you open up the program. And you'll notice here it says something about a job number. You can, if you do tracking on your programs by some numeric system or whatever, you can fill it out accordingly. But the key that we want to do today is take a look at the application down below here. It says parallel transformers. Okay, so I'm going to click on it. It gives us a message. It says transformer secondary conductors must be parallel runs of equal size, and the transformer maximum percent impedance deviation must be within 7.5% of the average for the parallel units. Okay, and so what we're trying to do here basically is make sure that the impedances are balanced out as much as possible between the two transformers, okay, that we're paralleling together. And like I say, we're doing just two transformers here. Okay. All right, well, here's the program screen. The program pretty much deals with two pad mount transformers that we have here, T1, T2, kVA rating of transformers, and also the percent impedance of the transformers have to be identified. We're looking at a customer's estimated load demand being served from the transformers to a junction box. It could actually go directly from the transformers to the underground pull section in the service panels itself. So either way, you'll have the same number, whether you're terminating at a junction box and then going from the junction box with parallel runs directly to the panel, or you're coming directly from the transformer, each transformer going directly to the panel without using the junction box. The value is still going to be the same. Okay. Then down here is the schematic version of it, and it says over here to the left that's the percent deviation from the average impedance. And that's what we were talking about. It needs to be less than 7.5%. And the program actually computes that for you. So really all you have to do is come to the bottom section here and input the data that pertains to your particular project. So what I'm going to do first here is make an assumption here that the customer that we're serving with the two transformers, the commercial building or industrial building that we're serving, has a kVA demand of 856 kVA. All right, well, before I do anything, I want to transform that 856 kVA into amperage. So I'm going to do this. Go back to the master, and this says transformer full load current calculator. I'll click on it, and I want to come up with my amperage demand based on 856 kVA. Well, these are just standard transformers here, but I can do a customized load information as far as determining amperage demand for an equivalent kVA by coming down here. So I would put 480, and I said 856 is the kVA demand, either estimated demand or actual demand from a reading that we got from a billing, customer service billing information. So I'm going to say calculate here, and you see that the amperage demand turns out to be 1029 amps. Okay, now that I have my amperage demand on the two transformers that I'm going to have in parallel, I can go forward. So let's do this. Go back. All right. So now I can fill this out at the bottom. I have three-phase is my power requirement here, and it's going to be 277,480, and it says customer's amperage demand. That's what this is up here. It says customer's amperage demand. So we found it to be 1029 amps based on either looking at the plans and load calculations or taking historical maximum demand from the meter reads. I have here, I want to use a 500 kVA transformer, and I have 3.5% impedance on that. And just for the heck of it, I'm going to show another 500 and 3.5. Okay, and since the two transformers are equivalent kVA and equivalent impedance, I expect my deviation to turn out to be 0, and I expect the load to be on each transformer to be equivalent. So let's see what happens when we calculate here. The values are shown in blue, and you'll see my kVA up here is 500, 500, 3.5. That's what we put in as far as the data, the base data. The deviation is what we expected it to be, 0. And the load on each transformer is exactly what we expect it to be, the same amount of load, based on the fact that the two transformers are theoretically equal to each other. So it should split evenly for this parallel. Okay? So we've done that. Now, take for instance, you have a situation where you initially install two 500 kVA transformers parallel to serve the structure, and you find out that we have a leaking transformer on transformer number 2. It needs to be changed out on the emergency. Hazmat is out on the site. So consequently, you check in the yard and see what you have available to match up with the good transformer. And you come to find out, I don't have another 500 in the yard. I have a 750. It's got a different impedance. Is it going to work? Well, that's where this program comes into play. So what we'll do is do what we just said. All right, I'm going to go back and I'm going to reset. Still 3-phase, 277, 480. Demand stays the same, right? All right. The only thing that's going to change is the second transformer. Okay, so the first one still says 3.5. Now I don't have a 500, but I do have a 750. And that 750 has an impedance value of 3.1%. So in essence, the first transformer remains the same, the second one changes. Are we going to have any issues with the transformers being parallel together? So basically we run the calculation here. You see that the deviation turned out to be 6.06%. We also found that the load on T1, the 500 kVA transformer, is 315 kVA, and the load on the 750 is 540 kVA. Well, everything's copacetic. You'll see here that we still have our same load flow. And the first transformer, T1, has a load of 380 amps and 650 amps. Well, what that really all tells us is that it's okay in an emergency situation to go ahead on and put the 750 in and replace it, replace the 500 that had begun to leak out in the field. So, ideally, you want to have transformers of equal value, but what this shows is that basically we can parallel transformers of unequal kVA, provided we stay within the deviation parameters that are set for the impedance. Okay, so that's pretty quick, but it is good for people to know, and especially if you're a working trouble situation where you're the on-call person and have to make a decision when the crew goes out to change it out in the middle of the night or whatever. Okay, so that is pretty simple, but it's a good little tool to have available to you in those situations. All right, well, I'm going to leave it there. Like I say, get in touch with me if you ever have any questions, and we can go from there.